Welcome back to my YouTube channel Grandpa Mathematics. In this channel, I am going to teach mathematics for 10th standard, plus 1 and plus 2. In this video, we are going to derive the basis of integration, and integration is nothing but the inverse process of differentiation. If you know the differentiation, then you find the integration is easier. So let us derive this formula. We know that differentiation of x power n, differentiation of x power n is n into x power n minus 1. This gives integral x power n dx is equal to, you have to see what. So I already told integration is the inverse process of differentiation. So if you differentiate x power n, we are getting n into x power n minus 1. That means if we integrate this value, that is integral of n into x power n minus 1 with respect to x, that is dx, this gives the value of x power n plus constant. Why I am writing constant? Because if we differentiate constant, we will get 0. So while integrating, we have to add a constant there. So now we want integral x power n dx only. N is a constant that we can take to the other side. So this gives integral x power n minus 1 dx is equal to x power n by n plus c1. c1 is nothing but c by n, is some other constant. So here power is n. This is valid for all values of n except n is equal to minus 1. N should not be equal to minus 1. So that means we can add 1. You can replace n by n plus 1. So integral x power n, I am replacing n by n plus 1. So n plus 1 minus 1 is n dx is equal to x power n plus 1 by n plus 1 plus constant. Here what we are doing, just we are replacing n by n plus 1. This integral, this is valid for all values of n except n is equal to minus 1. So that means we can replace n by n plus 1. So what is integral x power n dx is now x power n plus 1 by n plus 1 plus constant. If we differentiate sin x, what will come? Cos x. That means if we integrate cos x, we will be getting sin x. So integral of cos x with respect to x, that is dx, is equal to sin x plus constant. I already told you integration is the inverse process of differentiation. So differentiation of cos x, that is equal to minus sin x. So this gives what? Integral sin x dx is equal to, so we know if we differentiate cos x, we are getting minus sin x. That means if we integrate minus sin x, so integral of minus sin x with respect to x, that is dx, this gives a cos x. Now we multiply both sides by minus 1. So that gives integral sin x dx is equal to minus cos x plus constant. So what is integral sin x dx now? Is minus cos x plus constant. So if we differentiate cos x, we are getting minus sin x. That means if we integrate sin x, you know that minus cos x plus constant. If we differentiate tan x with respect to x, what will get? Secant square x. That means if we integrate secant square x, we will be getting tan x. That is integral secant square x dx, that is equal to tan x plus constant. So differentiation of cot x gives what? Minus cosecant square x. So this implies if we integrate cosecant square x with respect to x, that is integral cosecant square x dx, is nothing but minus cot x plus constant. If we differentiate secant x, what will come? Secant x is tan x. So secant x into tan x. That means if we integrate secant x tan x, what will be getting? Secant x plus constant. Now, what is the differentiation of cosecant x? What is the differentiation of cosecant x? It is minus cosecant x into cot x. So that means if we integrate cosecant x cot x with respect to x, that is integral cosecant x cot x dx, this is nothing but minus cosecant x. So here we can see if we differentiate x power n into x power n minus 1 is coming. So integral x power n dx is x power n plus 1 by n plus 1 plus constant. If we differentiate sin x cos x is coming, so integral cos x dx is sin x plus constant. If we differentiate cos x minus sin x is coming, that means if we integrate sin x with respect to x, we will get minus cos x plus c. So here sin x if we differentiate cos x is coming, and cos x if we differentiate sin x, of course minus. If we differentiate tan x, secant square x is coming. Cot x if we differentiate, minus cosecant square x is coming. If we differentiate secant x tan x. If we differentiate cosecant x, minus cosecant x cot x. That means you can see here tan means secant is coming, cot means cosecant is coming. Cot is nothing but cotangent. Cotangent. This is nothing but cosecant. This is sine, cosine. Cos is nothing but cosine. Okay. So let us see some more formulas. We know differentiation of sine inverse x. So this is nothing but 1 over square root of 1 minus x square. So this gives, that means if we integrate this, we will be getting sine inverse x. That is integral of dx by square root of 1 minus x square is nothing but sine inverse x plus constant. If we differentiate cos inverse x, what we will be getting? Minus 1 over square root of 1 minus x square. So that means if we integrate minus 1 by square root of 1 minus x square, we will be getting cos inverse x, or integral dx by square root of 1 minus x square is equal to, I will multiply both sides by minus 1. What will get? Minus cos inverse x plus constant. Here we can see integral dx by square root of 1 minus x square is sin inverse x. Same integral dx by square root of 1 minus x square is equal to minus cos inverse x. Both are right because these two have relation. We know sin inverse x plus cos inverse x is equal to pi by 2. This gives sin inverse x is equal to pi by 2 minus cos inverse x. That's why getting this value sin inverse x plus c. Same thing as minus cos inverse x. That is, c will be, both the c's are different. So, what is the differentiation of tan inverse x? We know differentiation of tan inverse x is 1 by 1 plus x square. So this gives integration of this is nothing but tan inverse x. Integration of dx by 1 plus x square is equal to tan inverse x plus constant. Again we know differentiation of cot inverse x minus 1 by 1 plus x square. Again we can write integral dx by, or 1 by 1 plus x square dx. Same thing, I am writing this way. It's nothing minus cot inverse x plus constant. Again we know that tan inverse x plus cot inverse x is equal to pi by 2. So that is nothing, this gives the tan inverse x is equal to minus cot inverse x plus pi by 2. So that means same thing we can write tan inverse x, same thing we can write cot inverse x. Constant is that both constants are different. So, what is the difference of secant inverse x? It's nothing but 1 by x into square root of x square minus 1. Differentiation of secant inverse x is 1 by x into square root of x square minus 1. That means if we integrate this value, we will get a secant inverse x. Integral dx by x into square root of x square minus 1. This is equal to secant inverse x plus constant. One more is the differentiation of cosecant inverse x. This is nothing but minus 1 over x into square root of x square minus 1. Same way, this gives integral dx by x into square root of x square minus 1 minus cosecant inverse x plus constant. So I assume you know all these values. Differentiation. If you know differentiation, integration is easier. We also know that differentiation of e power x is nothing but e power x only. So this gives integration of e power x with respect to x, that is dx, is nothing but e power x plus constant. Again, differentiation of log x. What is the differentiation of log x? Log x is 1 by x. This gives integration of 1 by x is log x plus constant. Integral of dx by x. This gives log x plus constant. So here integral dx by x is equal to log x plus constant. That means if we differentiate x, we are getting dx. Then the value of the integral will be log of the x plus constant. This is how we are going to write. If you differentiate the denominator and if you get the numerator, then the value of the integral is log of denominator plus constant. What is the differentiation of a power x? It's nothing but a power x into log a. So integral a power x dx is 1. So if we integrate this, a power x will come. Integral a power x log a dx, this gives a power x plus constant, divide by, we'll divide this by log a. So integral a power x dx is equal to a power x by log a plus constant. So that means integral a power x dx is a power x by log a plus constant. Here a is a constant. Okay, these are the basic integration formulas we had derived. And integration is also called as antiderivative of the function, given function. Now we will revise some of the formulas what we have learned so far. So we have already derived all these formulas. Integral dx by x square plus a square, integral dx by x square plus a square is equal to, if you put x is a tan theta, a square tan square theta, a square once you take outside tan square theta plus 1. So this becomes a single term. That means you have to remember that some tan theta is coming. So integral dx by x square plus a square is 1 by a tan inverse x by a plus constant. Then the same thing, integral dx by x square minus a square and integral dx by a square minus x square. For these two integrals, 1 by 2a will come. That's written 1 by 2a times log of, here x square minus a square is coming, so x minus a by x plus a plus constant. We have to remember x minus a is coming, so x minus a will come on the numerator. Here, if you multiply this integral by minus, we are getting this. So that means there is a minus sign here, minus sign, this will go here. N log m is nothing but log m power n. When minus 1 is coming here, we have to write this reciprocally. X plus a by x minus a will come. So this will be nothing but 1 by 2a times log of a plus x by a minus x plus constant. Reciprocal, x plus a by x minus a, We know modulus of x minus a and modulus of a minus x both are same. We are going to take modulus means we will be taking only the positive sign. Now integral dx by square root of a square minus x square with the square root. So in this, why I taken square root of a square minus x square? In this, if you put x is a sin theta, then a square, a we can take commonly outside 1 minus sin square theta, that will become cos square, that will become a single term. So sin theta is coming. So this value will be sin inverse x by a plus constant. Then other two integrals, integral dx by a square minus x square, next will be a square plus x square, I'll write x square plus a square. This is value of this integral is log of, when it comes like this, value of log of x plus, we have to write the whole thing, square root of x square plus a square plus constant. And value of this integral dx by a square minus x, a square plus x square minus a square under root, this again log of x like this x plus the same thing, whatever comes here, no, square root of x square minus a square plus constant. So in these three integrals, when you see these three, we have to remember together. Dx by x square plus a square means 1 by a into tan inverse x by a will come. For other two integrals, 1 by 2a log will come, then you have to remember like this. When square root is coming, dx by square root of a square minus x square, for this sin inverse x by a will come. The other two, log of x plus whatever comes here. Okay, for other two integrals, the value will be log of x. What x means, whatever comes here, we have to write here, plus again the whole thing, we have to write there, plus constant. Then integral square root of a square minus x square dx. Integral square root of a square minus, here a square minus x square, square root of a square minus x square is coming in the denominator. Here we are writing integral square root of a square minus x square dx is whatever comes here x, that x we are writing x by 2. X means whatever comes here, we have to write here. X square means x by 2 into the whole term a square minus x square square root plus whatever comes a square, this a square by 2, a square by 2, then you have to come to this integral. What we are getting? This value. This value we have to write here. Sin inverse x by a plus constant. Second one, integral square root of x square plus a square. So how we are writing? A square minus x square, next is a square plus x square, that is named x square plus a square. For this again x by 2, x means whatever comes here, no? X square means here put x a, then the whole thing, square root of x square plus a square plus again a square by 2. For the next term, x square plus a square, square root of x square, here in the dx by square root of x square plus a square, the whole thing we have to write here. This whole thing we have to write here. So log of x plus square root of x square plus a square plus constant. Then for this square root of x square minus a square dx. Okay. Now you can tell what will come here. Yeah, again x by 2. Again same thing, x square minus a square. Here one thing you have to remember, for first two plus will come, the third one, when x square minus a square is coming, minus will come. Minus a square by 2. For this, what you have to write? This one. X square root of x square minus a square. Here this comes in the denominator. This whole thing you have to write here again. Log of x plus square root of x square minus a square dx plus x square minus a square plus const. All these formulas you are supposed to remember to do problems. That's why I am explaining all these things. Now let us see these integrals of this type. Integrals of dx by ax square plus bx plus c this one, integral px plus q by ax square plus bx plus c dx, and integral px plus q by square root of ax square plus bx plus c dx. Okay, after simplification, this integral reduces to integral dx by x square plus a square form, or integral dx by x square minus a square, or integral dx by a square minus x square. Out of these three, it will reduce us to any one of those three forms. When we simplify this will reduce us to integral dx by square root of a square minus x square, or integral dx by square root of x square plus a square, or integral dx by square root of x square minus a square. It will reduce us to any one of these form. Of these two integrals, we have to take, let px plus q, that is equal to a times differentiation of ax square plus bx plus c plus b. You have to write numerator is equal to a times differentiation of denominator plus b. That is, numerator is equal to a times differentiation of denominator plus b. Afterwards, we have to equate the coefficient of x and equate the constant term, get the values of a and b. Here a and b are arbitrary constants. Get the values of a and b. Then for numerator px plus q, we will write these two values. Then this integral, these two integrals, we can write as the sum of two simpler integrals that will be in the formula form. Suppose if the rational expression is x cube plus 7x by x minus 1 whole square into x square plus x plus 1, like this. Then how to write this now? Degree of numerator is 3, denominator is 4, so it is a proper fraction. So x minus 1 whole square is there. So for that we can write a by x minus 1 plus b by x minus 1 whole square. Plus, when this is not possible to factorize and degree is 2, we have to write degree is 2, so that is Cx plus d, 1 degree less than this one, x square, Cx plus d by x square plus x plus 1, like this. Then we also seen integration by parts. In that, integral first function into second function into dx, integral first function into second function to dx, both are functions of x. So out of these two, one we have to integrate. So integrate one function into other function. So out of these two, we are integrating one into other function. Other function we are writing as such only, minus integral of integrated function. This is the integrated function. So this value we have to write here, and differentiation of the other function. Dx. So while out of these two, I already explained which function we have to integrate and which one we have to differentiate. Then we already learned integral e power x f of x plus f dash x dx, integral e power x into f of x plus f dash x dx. This is nothing but e power x into f of x plus constant. Then integral a sin x plus b cos x by c sin x plus d cos x dx. This integration, the numerator, let the numerator is equal to a times denominator plus b times differentiation of the denominator. So when you do this and equate the coefficient of sin x and cos x, we will be getting the values of a and b. Then this can be written as a sum of two integrals. Thanks for watching. We will revise some more problems tomorrow. Till then, bye.